this last session of the day, we will have talks about projects that involve some academic collaborator and other collaborator. And after this tutorial, we will have a reception, so plan to stick around. We will have a reception with some food and drinks, so plan to stick around to chat a bit more. The first talk in the session is by James Honaker, and is on PSI, a platform that they developed.
Thank you, Marco. I'd like to thank Marco for this opportunity. He's a good colleague and very hard to say no to. And I quite dislike giving talks, but this is a good opportunity. I tremendously dislike giving talks, so thank you, Marco.
But we like your talks.
Okay. Well, Alex described her work as bridging work, or if she didn't, she could have. As part of the Privacy Tools group, she bridges legal ideas and legal concepts with these differentially private algorithmic ideas and theorems. When I joined this project, my background is in applied statistics, quantitative social science, statistical software. The idea was I felt we could do some bridging work to take things that existed that were coming out of the Privacy Tools work and make them practical. And the remit was, let's take all these algorithms that we know how to create, that we know are differentially private, let's tweak utility and turn it into the kinds of things that statisticians would actually use. So what does that mean? They have to have high utility, and they have to understand how to use them correctly. And that seemed like an easy task. And my daughter was born right about the same time, which is really, really useful because she's almost 5, and that lets me remember how old she is. How long I've been on this project is how old she is at any particular time. But it has been a long project, and this is the idea of extracting utility, making things usable, both in terms of having high statistical utility and answering the kinds of questions that are of use to scientists, is really an ongoing research project. And I'm going to sketch over a bunch of things. I'm going to talk about the system that we have built some of these things into. Think about DP as a deployable system. Partly, I think I'm going to re-emphasize things that we've learned over the last few years, which are the same kinds of things that people have been saying in all the talks, particularly in the morning sessions, about what are the kinds of issues that are necessary for real deployment, and this is an interesting workshop to really focus on that. Okay. So my background is in say the quantitative social sciences. This is a really nice quote by Mercé, who runs one of the repositories. I'll talk about how science repositories open up scientific data for secondary reuse, for replication, for discovery. It's really well written, but it's too long. So this is the basic idea, that in the sciences, replication is the foundation. If I can't replicate a result, how do I trust it? And if I can replicate a result, then I understand it well enough maybe to build on it in some sort of progressive way, or reuse that data to do something else with it. Okay, so the idea of secondary reuse and replication of data is very central to the scientific method. You have now these norms that funding agencies expect data that has been publicly funded to become publicly accessible. We have this replication crisis in the social sciences where we don't know which results might be functions of methodological flaws or don't generalize. All this requires, this emphasis lately on replication and reuse. We have these large building repositories. I'll talk about Dataverse as one, but there's Zenodo and Figshare and all these other places where data is accumulating in large open troves, unless that data is sensitive. And then in that case, these repositories don't know what to do with it. Mostly, they've got data. Repositories are where data goes to live for indefinitely, unless the data is sensitive, and then repositories are where data goes to die. They get put into locked boxes. Maybe there's a process that's very, very labor intensive by which somebody might be able to get some access to that data. But except for larger scale projects, Census is a great working example, but other projects which have devoted staff to fielding queries about what data is, running analyses on the data so that people can discover whether there are enough observations of the particular type you need to run the analysis. Outside researchers don't necessarily have the time or the inclination to go through IRBs to get access to a data, and also maybe have to go through the IRB of the original collector and get the permission of the original data owner to find out that that data actually wasn't the data that they needed, and it was some other data in that repository. So the goal here is how can we facilitate sort of replication and reuse and discovery of data sets that are sitting in these repositories, but we can't open up the raw data because it's sensitive to researchers, through the curator mechanism, through allowing differentially private releases of statistics, either in some sort of one-shot release or perhaps through interactive queries where we trust researchers enough perhaps to give them their own budgets. We'll talk about different tiered access models has come up a lot, even in Alex's talks. We'll talk about what that might mean here. Okay? So here's our overview, though. The goal of this is quite different from some of the applications and deployments that we've discussed previously and that might come up in the rest of the week. I'm teaching a class right now with Salil Vadhan on trying to investigate and explain to data science master's students. We're working through all of the deployments that we can find, general purpose deployments of differential privacy, and thinking about how are they coded, what are the systems, what are the tasks that they're trying to accomplish. So actually working through the actual deployments of differential privacy. Some of you might say that's a really, really short class, right? So so please try to make this a harder class. Create more of these things. The goal here in this particular deployment is that we don't know ahead of time in a repository setting what the next data set's going to look like. Right? We don't have somebody tuning algorithms to very, very specific tasks or to very specific statistical models. Or to very specific queries and coming up with a differentially private algorithm that's perfectly tuned to that kind of release. Don't have the manpower for that. Don't have maybe even the technical capability, don't have the scale for that. So the goal here is data sets are constantly coming into the repository. We want some general purpose algorithms, a general purpose toolkit that will release reasonably good summary statistics so that people can understand and discover what these data sets are that are sitting in these boxes when they can't see the raw data set through a centralized curator model. Okay? So we want it to be accessible. We don't want a DP expert in the loop. We just want sort of find data sets, find algorithms that can be tuned to work reasonably well across the range of data sets that we're seeing. General enough to work across the types of questions that people are looking at in these socials. I say social sciences, but really I should say sensitive human subjects. There's sometimes health or public health data sets in there also. And workflow embracing. So these things are not going to be used if the scientists who are coming to discover the data can't understand what the results are or can't access these results outside of the statistical toolbox that they've trained on. So how do you get things to work within their own workflow? How do you pitch this in a way that seems additive, that we're not shutting doors to people and saying you can't have that data, but instead saying there are these data sets you never would have gotten access to otherwise. Here I'm giving you some access. Yes, it happens to be through a curator. Yes, it happens to be noisy. But making this an additive process and not a subtractive process. We're not taking data away from researchers. We're opening up data to researchers that they would otherwise not have any or easy access to, learning about. And then this tiered access model is also a part of our goal. Maybe there are settings in which this might not be the only mechanism by which people get access to that data. So it could be tiered access here might mean that when they've discovered the data set and they're absolutely certain that it's going to fill their need, maybe then they do go through an IRB and get access to the raw data with the right privacy protections. Or maybe there are researchers who are trying to discover data sets at different levels of trust, and we're willing to grant individual epsilons, so supposing that we trust them enough to abide by some data use agreement that we construct to say you're not going to collaborate with other researchers to pull epsilons. Okay? So that's the overview of what we're trying to do. It is a piece of a the PSI itself is a piece of an extensive set of tools, which Alex has already alluded to, so I will piggyback on that. There are a large number of people who have contributed to this project over the past 7 to 8 years now. However, well, the one thing I will say is, so it's interdisciplinary in the sense that there are several different centers. There's the Berkman Klein Center doing legal reasoning. There's the CS theorists over in the computer science department. There's the quantitative social scientists over IQSS. There's LaTanya Sweeney in her privacy attack lab. People like Micah over at MIT Libraries. The main point of this slide is that there is a lot of white space left, and if people want to join, this is please talk. If anything here intrigues you and you think, oh, I have algorithms that I think your system would use. Would you like to implement them for me, or would you like me to implement them for you? Please join this. Or I have use cases for sensitive data that I think match very, very well the sort of architecture that you're building here. I'd love for you to consider it. Please, people come and go. Not everybody here is at Harvard, but do feel free to visit us for a year. And if you want to join this board, there's so much space left. Okay, so some of these tools, I'll give a quick overview of some of the tools in the sort of the broader system, and then I'll concentrate on one of these little arrows here. So in order to make things usable at a repository level, we first need to understand what's the sensitive data and what isn't. Okay, so there's a lot of data in Dataverse, this repository that I'll be talking about, that is like astronomical, not astronomical as in big, like literally pictures of stars. That doesn't require the privacy preservation. Maybe differential privacy still helps for generality, okay, but doesn't require privacy preservation. So a tool system that is able to extract from the user as they're depositing their data into this repository, what do you know about your data? What might be the possible sensitive topics here? What are your ethical obligations to your subjects? What kinds of data use agreements have you promised your subjects? Extract that and understand what's the level of sensitivity. Okay, so we have this. So here's an example of a series of interviews that are structured around a directed graph, and then code data sets into these levels, which get embedded into the metadata of the data set in the repository in a way that's actionable from that point on. We know the data set has some machine actionable set of policy rules, both about security features and access credentials. So this is one product of this system that might interest you. If people do get access to data sets, something that we've seen a lot of is that the negotiating terms of use to sensitive data sets when they are finally going to be made available can take an awful lot of manpower, particularly lawyerly manpower. So there is a project to try to automate that called Robot Lawyers, which takes in another set of interviews with the owner of the data and the repository that it's being stored to understand what the logic rules would be for processing that data, and spit out in a more automated fashion a data use agreement. Okay, so a series of logical rules about what's permitted on the data set can translate into a license agreement in a way that expedites that process. Alex has already talked about bridging work, which is a central part of this, understanding if we want to get to public access statistics, things that can be released to the general population that are summary statistics, why we can translate data sets that came in as red into summary statistics that go out as level green or level blue. That's an important part of this process. But the thing I want to focus on from this point on is just this last little arrow here, which is if I have sensitive data, how can I generate public access statistics, summary statistics of the data set for discovery, and possibly summary statistics that are actually being generated on the fly by interactive queries, by people who have their own budgets to ask additional questions of the system in order to generate these things. Okay? So again, there's been a lot of contributors to this system. These are authors on a system level paper that I'll talk about in a little bit, or I'll point you to at the very, very end, including a graduate student going on the market if anybody's looking. Also a fairly large pool of developers who have been working on this, both at the repository and within the computer science department, and also within UI and UX design. So I'll actually focus a fair amount on making things usable by having programmatic and API and GUI interfaces that direct the user and constrain their ability to do things that violate differential privacy when composing across a statistical release. And also a large number of postdocs and visiting fellows and summer interns. And if you want to join this list, please talk to me if any of this sounds interesting to you. We have really been trying to push very recently to make this increasingly a more community-oriented and less Harvard-centric group. And I'll talk a little bit about the ways the library are expanding and other universities that have been contributing recently, especially such as BU. So PSI, it's named after the ancient Greek emoticon of somebody shrugging. It stands for Private Sharing Interface. It is a system of 4 individual tools, a budgeter, which I will guide through because it's the easiest thing to demo because it's very graphical, that guides the novice into making reasonable budgeting decisions about their epsilon across the statistics that they would like to release to future researchers. And then a repository that's going to store that data, hopefully in secure ways. An interface for understanding when these statistics are released. Well, they come from distributions and they have noise and they have confidence intervals, but those confidence intervals are to samples and not to population. So how do you translate all that into in a reasonably intuitive way to a non-expert? So an interface for that, and then underlying this a library of algorithms. Silence, presently in R, and we'll talk about maybe porting that or binding that to other languages as use cases evolve. This is our system level tool. I'm going to focus on the budgeter because I think most of the interesting questions about what makes for a good system sort of project into decisions that were created as we tried to build out this sort of usable privacy interface. Okay. I said I was going to talk about the budgeter, but one page on our library, because so this is in and of itself perhaps the one thing that is usable without any of these other components. If you're interested in a library of functions, it focuses on univariate statistics, the kinds of things that you could imagine are useful for understanding what a variable is, and for which there's lots of good algorithms out there. A fair amount of our work has been to find competing algorithms that exist in the literature for particular statistics that we think are of use as summary statistics, and then empirically test what tends to be the utility of these things in the scale and types of data sets, the data-dependent utilities that you see in the kinds of data sets that are coming through the repositories. I'm not saying that the algorithms that are picked are done in a data-dependent way, but if there are clear winners, then that was something to learn. Often there's a lot of work in the literature on obviously on proving that you meet the differential privacy definition, and it's harder to characterize what the utility might be for these algorithms. And then also basic statistical estimators. So that includes things like linear regression, low dimensional, just a couple of covariates, a very simple way to explore data sets. Can I predict this outcome as a function of these 1 or 2 variables in a linear fashion? But also things like matching algorithms. If you're interested in understanding, if the person comes to the repository and is interested in learning causal relationships between variables, treatment and control observations, how to match them up to make non-parametric differences, how to do difference of means tests for causal inference, those basic statistical estimators. Some work we've been trying to press on how you do hypothesis tests, how you come up with confidence intervals for making hypothesis tests. All this is continuing work, but this is a focus of the library because of the focus on doing open science inference. And again, this is written in R. It's class-based to make this increasingly modular. So if you have an algorithm you'd like, it might be that component parts of that algorithm already exist in our library, and we might be able to implement it by only adding whatever your novel twist is. If you have things that you think would work really well in this library, do tell us. Ira is raising her hand, and Adam is here somewhere. At BU have been working heavily on expanding this library and bringing in more statistics. So really would like to converse with people over the next week about anything they think might make sense to add here. So this library is sort of underlying at the back end. Again, the data itself in this workflow is going to this repository, Dataverse. Dataverse is a federated way, a federated repository for scientific data. It's an open source platform. There's currently 27 instances of this around the world. 500 institutions have researchers with accounts. There's 75,000 social science data sets in the largest of these. That's the Harvard repository. But you see that there's a lot of use of this in the quantitative social science community. Our tool interfaces with Dataverse. We'd like to integrate with other repositories too, so that we're not trying to lock people into this particular setting, but they're across the street, so they're easy to work with. Here's the fundamental problem: is that if I drop data into the repository and it has sensitive data, and I declare that, it's going to get this little locked symbol. And when somebody comes along and says, "Do you have any data on whatever the keyword is here?" This might possibly come up if it's got a public keyword, but there's no way to download or explore or request access to sensitive data. There's just not the capacity to do that. In this model, we have people who are in our sort of repository-based use case. We have a data depositor who's the owner of the data and is ethically or legally responsible for that data. We've got a curator who's more of a librarian, let's say a data librarian who's charged with archiving data in the long run, and analysts who are coming along trying to discover data sets. Okay? And they come along with different goals that we were modeling here. Different levels of trust. These analysts themselves you might not trust at all, or they might maybe have some, like an ORCID ID, something that verifies that they're an academic researcher and a unique individual. Maybe they're semi-trusted and we're willing to give them a small budget of their own. Okay? In this setting then, the question is, how do we build a layer? How do we build a curator to make it easy for the depositor to explain what it is they know about their data and maybe make some choices about budgeting, and similarly allow some analysts who are semi-trusted to also make queries of this data set. Okay? And these are the kinds of questions that we've had to ask and we've been confronted with trying to build this out. Practically, in order for differential privacy to be practical to a scientific analyst, what are the kinds of things that they need? Obviously, this is the groaning question in the room, right? Like, of course, they need to be able to understand what epsilon is, and we all know that, but we all kind of want to punt on that question. I realize that people seriously address that, but that is something that is heavily important to understand how we interpret epsilon and how we set a privacy protection level as appropriate to different types of sensitive data. How do we explain DP not in a technical way, but in a sort of a pedagogical way to an applied researcher? How do we express what these errors are when we're talking about a release compared to the sample statistics? How do we incorporate that into a measure of uncertainty if we're doing an inferential task, like a confidence interval back to a population? How do we do variable transformations? How do we allow that? That's a standard part of statistical modeling is I've got a data set, I need to make a new variable that's a function of other variables. How do we test in a way that's provable that if you want to create a new variable on this data set before spending any of your budget, that transform itself is safe. So we have a sort of a Haskell prover for showing that variable transformations are row by row. And then these models that I talked about earlier, including things like the bootstrap for building confidence intervals. So those are changes those are things that we've had to emphasize in the research projects of the people in this project. But they're not the only people who answering these questions by say the DP community are not the only people who have to change, obviously. the analysts themselves, the scientific workflow has to change in order to use this system. People are trained to, first thing you do, open up the data set. Make sure you understand what it is. Look at the raw values. Make sure those columns look right. I'm not going to do that here, and that's very uncomfortable when you're trying to. We've done use case studies and experimental studies where we bring in researchers and say, okay, try and use this curator to answer this specific problem on the data set. And the thing that it's really hard to break them of is, okay, but first I need to see the raw data to even understand what this data is. That's not going to happen. Okay. Similarly. You're generally trained to, if you've got a model, there's a better model. If you've got a model, how do you reduce the error in that model? Wait, you're telling me your system's going to be adding noise to this model. That's mind-blowing, right? You could be doubling standard errors by having a conservative epsilon. Obviously, some small effects are going to be drowned out by that noise. Obviously, that just runs counter to the idea that the sort of purpose of a statistician is to wring out every single last ounce of knowledge that you might get out of that data set. You're also trained to how can you write that next clever paper that reuses data you've already collected? Well, what's the problem if epsilon's going to be exhausted and you can't go back to that data set? So these are sort of things that you have to retrain scientists to think about this. Similarly, there's a lot of changes for curators. There's a lot of work to put on the repository that hopefully if the system is robust, it's not too much work, but lots of system level tasks that we don't normally think of as part of the differentially private algorithm. Like, what's the source of randomness that's being used by this repository? How are we checking for leakage? How are we dealing with missing data or outlier detection or all these other pre-processing steps that we might not have algorithms for? Is the repository doing this? Are they doing it in a way that's data dependent that might be leaking information? And then similarly, okay, so UI UX testing, that's always important, but never more so than in a system where you can't actually see the raw data, right? Having a UI system that makes interacting with data intuitive even though you can't touch the data is particularly important here. Okay. These are things that our tool is focused on. Again, exploratory analysis, so ways of learning what that data set actually is to learn if that's the data set perhaps you want to gain access to and go through the IRB. We had some informal chats with people at IRB and particularly with like some demographers who have a sensitive data set. And they have two people whose entire job is just to field queries about what their data set is. They have staffers to do that in this large project. And they say about 1 in 10 pans out. So 9 out of 10 people are coming thinking that's their data set and it isn't. So if you can automate that and provide access to other data sets that do not have that level of staffing ability, then you would open up a lot more data and make the correct matches between researchers and the data that they're trying to discover. Okay. I talked about variable transformations, missing data, tiered access. Let me walk you through the workflow here. Actually, this is more of a slide in case my demo fails, but somebody's going to come along. They're going to upload a data set using the Dataverse UI. Then they're going to make that owner is going to make some decisions about how they want to partition their epsilon, if they're going to release some summary statistics to the broad world. An analyst is going to come along and discover that data set. Then they're going to be able to read that metadata that's been released, possibly in a visual way, or possibly they just read the released values. And if we trust them enough, they can make some additional queries through this budgeting interface themselves. Let me show you how that budgeter works. There are so there are GitHub repositories for this if you want to play with the code, and there is a live demo of this that is up on a cloud instance that you can look at whenever you want. I'll show you the link at the end here. If you go to the slides, you can always see this demo, but I'm going to instead play it locally, just in case the internet's slow. So we can get over. It seems to be as big as it's going to go. Okay. So, a user's coming along. This is somebody who owns a data set. I'm logged in. I'm going to add a new data set into the repository. So I'm going to enter some information and some metadata about it. And this is a fairly long process, so I'll skip ahead. We do worry a little bit about exhaustion. That is that users have to do a lot to upload data in the first place. It's then an extra step to go through the budgeting process. Let me skip ahead just a little bit. Now what they're doing as they finally get there is to say, my data is sensitive, so you're going to have to request access. This data cannot be publicly shared with individuals. Okay? So they've just uploaded their data set. I skipped ahead, hopefully to the right point. Let's see, is it still running? Yep, it is. Okay. So now I'm the owner. If I've added the data to the data set, I'm going to, maybe I skipped too far ahead. Let's see what happens. Yeah, press that button. This is me yesterday, clearly tired. Okay, I'm going to publish my data set. Yes, it's going into the repository. Now, if I switch user and I'm now an outside person coming along in private modes, and I try to find this California PUMS file that I uploaded and said was sensitive data, even though it isn't, and I find it by keywords, I'm going to find out that there's nothing that I can share on this data set. There's nothing that I can read about it. Okay, when I click on it, it's not going to have any ability to understand what's going on in this. It's just completely locked up, and I have to request access, which means ask the original author to make me an exception. So if I go back and I become the owner, then I'm going to say, hey, let's open up some privacy-preserving data previews. We'll give a brief explanation of what differential privacy is, and if you want to do this, kick it out to this service. Okay, so you're going to have to know a little bit about what differential privacy is in order to use this as the data owner. Okay, so we have a few pages that are absolutely required reading, but as little as we think you need in order to use this system effectively. Here's a little progress bar. You'll see there's actually several pages we're going to have to work through. One of that was to talk about what differential privacy is. Now a quick explanation about what these parameters are and what epsilon means, and some hypothetical use cases where some epsilons and deltas might be appropriate for those use cases. So I'm going to need to make a decision. I could have just possibly clicked one of those, but I'm going to use epsilon of 0.05 and delta of 10 to the minus 8. Okay. Hopefully that makes sense. I think my data matches one of those use cases in those stories. I need to make some declarations about what the variable types are. The types of the variables themselves can leak information, even if they're automatically gleaned. So we need the user to confirm the types. Makes sense. Whether or not something is Boolean might reveal whether or not a third category ever existed in that data set. So types of data can leak information. And I'm going to need some bounds and some ranges, some metadata. So I just filled in the ranges for all my continuous variables in the data set. Okay? And now I'm going to release some statistics. So I am going to find out what the statistics are that I can possibly release on this age variable. You see that it's being explained in the top. And I'm going to release the mean. And I have all the metadata that I need in order to run this algorithm. And so I'm being promised that if I release the mean at my epsilon of 0.5, it's going to give me an error of 0.5. I just asked for a histogram also. It's not adding this to my set of summary statistics yet because I hadn't filled in all the metadata. So for this algorithm, I'm going to need to bin the data into 10 bins. And now I have some promises. And these promises can be explained in natural sentences as I click on each of these with 95% probability. The true mean in the sample is going to differ from the mean that's released by no more than 1.198 units for the mean. For the histogram, there's a different interpretation. But every statistic has a natural language explanation about what the error promise is. I opened up the epsilon column. We don't necessarily show it to the user, just so that we can see what's going on here. The epsilons are being evenly partitioned across the statistics that I'm generating. This is how I'm dealing with missing values. Very crude, but we have to do something. So Booleans can be assigned either a random value or their own category. Continuous variables can be drawn from an interval that the user might decide. I might want to reserve epsilon for future queries, so I'm using this slider here. Let's see what else. I've entered in 2 of the underlying parameters here for epsilon delta. It might also be the case that my data is a random sample of some larger population, and that thing is secret. So here, let's say This is some PUMS release data. Let's say we don't know who these individuals are, and they're a random sample of 39 million people in California. Okay, so my epsilon was 0.05, but my functioning epsilon can be larger than that if I'm willing to use secrecy of the sample to boost my functioning epsilon. And now here's where I'm doing some budgeting. Maybe after I've read these sentences, that error seems too large to me. Mean age, that's a variable I really want to convey to somebody who's going to use this data. So I'm going to change that error. Okay, and if I want that promise error, then the library is going to say, okay, then your epsilon, you need to spend more epsilon on less epsilon actually on that particular statistic. I'm adjusting the errors to match how important what I think are reasonable for these summary statistics, and I'm getting back out epsilons that compose by advanced composition to meet those errors and spend all of the epsilon that I have as a functioning epsilon that I'm not reserving for future queries. I'm talking a little slower than I wanted to, so let me back up. But I created a group of variables that I'm going to release a multivariate statistic on. Here, age, sex, and marital status. And if I add that into my model now, I can release something like, say, an OLS regression might be a statistic. So predicts marital status, the metadata that I need on age in order to create that regression to bound this numerical variable was already in the data set, and I'm getting a promise that might not necessarily be as intuitive as the other promises. That's a promise on the likelihood, unfortunately, for that. As I said, we try to describe as much differential privacy as is necessary to use the interface, but no more. There are links to quick explanations of differential privacy built in as a manual, drawing on the pedagogical paper that the group released and Alex has mentioned earlier. At some point, I'm going to decide that's my release, and I'm going to tell this query, okay, I think I'm done. This action cannot be undone when so I'm fine with that. I'm going to release my statistics. And now I am going to take those epsilons across those statistics, send it to the library. The library will compute the releases and write it into metadata. And so here is a quick flash of that metadata, but it's being written into a JSON format that's much more extensive. It's not just the releases, but it's what was the mechanism that was used, what was the error distribution that's being used, what's the standard deviation on that, all being written into JSON that can be stored into the repository. And now a user can come along and say, now there is some information that they can open up. If there are summary statistics that they can see of that, they could look at the raw JSON file, but it's hard to understand. Instead, they might be able to visualize it through this visualization tool, 2Ravens, which is a way of visualizing data through JSONs without touching data. Also, I can download those differentially private statistics, and this is what that JSON format looks like. You see that there's a lot of information in there about exactly how that release was generated. Okay. Any questions about the underlying demo? Okay. Great. In a few remaining minutes, then, let me go back to my slides. Okay, so usability is really important here. A lot of the work over the last several years has been on building and tweaking and trialing and tweaking again and bringing in user studies and tweaking again that interface to try to make it as intuitive as possible so that people can basically trigger differentially private releases without being experts in privacy. It is an onerous task, no matter how fast I try to explain it, but you can see you can release statistics in a small number of minutes. There is this standard in usability out there called the System Usability Score, which is a way of comparing in some abstract way a certain set of dimensions of usability across platforms. Excel gets a 56.5 point scale on this thing. Your GPS probably gets around 70. We, depending upon our version, have been somewhere between your GPS and your iPhone. So we are not as usable as your iPhone, but we are far easier to use than Excel, and applied domain scientists use Excel all the time. So that was sort of like, we'll do better than Excel. So there's a paper released in archive if you want to see more about how we've been conducting usability trials. What's the underlying conclusion here? We're really shooting for accessibility. That is, the non-expert can make differentially private releases without the intervention or the use of a statistical consultant. Generality, that we have algorithms that work pretty well aren't highly tuned, aren't necessarily the best algorithm for that data release, but work pretty well on the next thing coming to the repository. Pretty easily incorporated into the workflow if you already know how to use Dataverse, so low overhead. We think those things are achievable in this prototype. I'd like you to go play with it and tell me what you feel. In the near future, these are things what we're trying to do. So we have this library. As I said, people at BU are spending time particularly expanding the things that are in that library. But it has been focused. It's been people that we can hit up to add things to that library. We would love this to be more of a community-driven project if other people would like to either contribute or guide implementations or even make suggestions about things that belong in this library. I'm previewing a little bit Salil's talk on Friday, where I think he'll pitch some of the future directions that he would like to open this up to be a more crowdsourced, more community-driven project than a Harvard project. Similarly, the architecture itself has been very sort of specially engineered to work well with Dataverse, but we would love to have sort of community input for what a better vetted architecture that works and integrates with lots of other possible deployments or data portals might look like, and how to make an architecture that's sort of reusable in other domains. We run our code on the private data because we are integrated with the repository, but we want this year to move this to a code service model where you come to PSI as a service and say, I would like to make these releases, and PSI generates code to make that releases and then gives it to you in a certified fashion for you to go run wherever the data is stored, so the data doesn't have to come to us. Maybe by having some sort of certified image that can be run on the data wherever the data is being held. People in industry don't want to drop their data into an academic repository in order to allow outsiders access to their data, for example, but they might be willing to run data that's been verified and attested and certified on their own systems. And then we'd like to work much more heavily on having actual use cases that demonstrate the utility of this approach. So this is a quick preview of what Salil wants to talk about in more detail about expanding plans and a broader project and maybe a reboot on Friday. If you're interested in these things, there is this live demo. Go play with the budgeting tool and tell me what you're interested in. There's a system level paper of Marco's and other people's up on Archive. Alex already mentioned this non-technical primer, but it forms a lot of the underlying manual and way we explain the system to people by Alex and Kobe. And then these usability experiments are really quite interesting. How do you deploy a system that's actually usable to the non-expert? How do you make people who didn't know differential privacy 5 minutes ago able to make a differentially private release? Okay. Thank you.
Time for one quick question.
So the issue of scientific reproducibility, is that something that's come up in the project? I mean, the fact that you're generating results here, but it's hard for somebody to reproduce them because of the nature of privacy. I mean, you're signing these...
Well, so that's why it's important not only to give point estimates from differentially private releases, but to also give some measure of uncertainty about what that point estimate is, and then think about, okay, so if I make a release of a model, is the model that's been released previously, possibly on the raw data, are these things congenial? Are they compatible? Is the model that you released plausible given my confidence interval for what that thing might be? I think that's one way of thinking about it, and I think that's why it's crucial to have sort of hypothesis tests. The hypothesis test might not be the null hypothesis. It might just be, could the thing you have reported have come out of this data set? Also, there are settings in the sort of computational social sciences where answers aren't deterministic, right? So if you got to impute missing data, the next time you run that analysis is a little bit different. So it's not the case that the fact, or if you're running a Monte Carlo Markov chain or something like that, you're going to get some noise. So it's not that
Yeah, but you can record that noise. You can report the noise that you used.
Sure,
Which
sure.
you can't do, obviously, in
Right. Yeah. So also, there are techniques that people in this room could talk to you about, like verification strategies, where the differentially private answer you get back is not the statistics, but whether or not some statistical model that you believe came out of that data set is true or not. These variables are statistically significant, yes or no. That's a very low cost answer to get back in a differentially private way. John either has a question or would like to give a better answer than I just did?
Neither. I
Okay.
want to continue that conversation because I think it is at the core of one of the issues that all deployers of differential privacy are facing, which is distinguishing between the replication exercise, the validation exercise, and the comparison exercise. And I think that your system can expose the entire workload. It doesn't have to expose the random numbers. And in that sense, I think that you could give a better answer that it is possible to verify that if the inputs have this schema, this calculation will produce that number, and the actual number you got was drawn from this random distribution. And you actually highlighted that documenting how you're drawing your random numbers is actually a very important feature of these. So we have to, replication isn't just if I take this data set of this code, I get this answer that I found in this paper. It's confirming that whole workload. And I think you sold yourself short in that sense that you do have a good way of exposing the workload for replication. Now we need to talk about validation. If I ran an alternative model on a similar data set, how do I calculate discrepancy between the model that was released the first time and the model that was released the second time? You need to be able to release enough information to do that as well.
So that's partly what I would express as being folded under reuse or extension or what term what have you.
But you do expose the workload, right?
Yes.
Your R code is in the
Yes, is absolutely public. Yep.
The schemas for the input databases, those are in the
And yes, it's all the schemas for the releases are schema.org, so you can take a look at what the JSON means and what the definitions are.
How did you handle the random numbers then?
So we use OpenSSL right now because there are like pretty clever, pretty simple attacks that we realize pretty fast on other kinds of shift registers that might be more typical. Sorry? Oh yes, I'm sure lots of people have stumbled onto that. Yes. But if you start asking a lot of queries about things that you already know the answer to, then you can see the random number generator and break it pretty fast. So having a cryptographically secure source of randomization is very crucial and not going to shock anybody in this room. But one of those things that isn't necessarily at the forefront of people's mind in this literature.
I suggest we keep some other discussion for the reception afterwards, and let's thank James again for academic collaboration on privacy.